welcome to Math Quiz. In this video, let me see an example under Fourier series. In the given interval 0, 2 pi, but here the function takes two values, that is in 0 to pi it takes the value f of x equal to x, and in pi to 2 pi it takes another value 2 pi minus x. And let me see how to expand this function as a Fourier series in the given interval 0, 2 pi. Here the length of the interval is 0 to 2 pi. That is 2 pi is the length of the interval. But the function takes the value 0 to 2 pi, it takes the value x, whereas pi to 2 pi it takes the value 2 pi minus x. Okay. Let me see how to find the Fourier expansion of the given function. Okay. So before that, let me have a short look over the formulas that we are going to use in the problem. So this is a very important formula, that is Bernoulli's formula. Integral uv dx is equal to uv1 minus u dash v2 plus u double dash v3 etc. Here both u and v are functions of x. Here u dash represents, that is du by dx, that is the first derivative of u, and d squared u by dx squared is u double dash, and u triple dash is equal to d cube u by dx cube etc. So here u dash, u double dash and u triple dash etc. represents the successive derivatives of u, whereas v1 is nothing but integral v dx, and v2 is equal to integral v1 dx, v3 is equal to integral v2 dx. That is, you have to integrate v1 with respect to x once, here twice, here thrice with respect to x. So here v1, v2 and v3 etc. represents the successive integrals of v. Then this is a very important formula that you have already known or familiar with this, that is integral x bar n dx is equal to x bar n plus 1 divided by n plus 1. This is a basic integral formula. Suppose if you are going to integrate x square with respect to x, what happens? That is, you have to raise this power by 1, that is x power 2 plus 1 divided by 2 plus 1, that is x cube by 3. Likewise, the derivative, that is d by dx of x bar n, you have to differentiate that the same x bar n means that is equal to nx power n minus 1. So here I am going to take, that is I am going to differentiate x square with respect to x. So let me see what happened. So first write the power here, that is 2x, and you have to reduce this power by 1. Okay, that is 2 minus 1, that is 2x. Okay, now integral sin x dx, sin nx dx is equal to minus cos nx by n. You know the formula for integral sin x dx, that is equal to minus cos x. So if it is nx, that is minus cos nx divided by n, and integral cos nx equal to sin nx divided by n. You know the formula for integral cos x dx, that is equal to sin x. Okay, here both here x having the coefficient 1, so no need to write divided by 1. Okay, if it is more than 1, we have to mention that in the denominator. So this is a general formula for sin nx and cos nx. Okay, now while substituting the limits of cosine and sine terms, you know the limit values, that is cos 0 is equal to 1, whereas sine 0 is equal to 0, cos pi is equal to minus 1 and sine pi is equal to 0, whereas cos 2 pi is equal to plus 1, sine 2 pi is equal to 0, whereas cos n pi is equal to minus 1 whole power n, whereas sine n pi is equal to 0, cos 2n pi is equal to 1, sine 2n pi is equal to 0. So this happens only when n is an integer, but in throughout 0 to 2 pi we have to take only integer value, so sine 2n pi takes the value 0. Okay. Now with this short introduction, let me give you one more hint about how to change the summation. That is, if the summation is from odd term to infinity, that is, this summation takes the values of n from odd to infinity. Odd to infinity means it will take only the odd values like 1, 3, 5, 7 etc. instead of taking 1, 2, 3. So if you want to change the summation from, that is odd term to infinity to summation 1 to infinity, what you are going to do here is, suppose inside the summation if you are having n means, so you have to replace this n by 2n minus 1, that's all. Okay, so definitely if you replace this n by 2n minus 1, automatically this odd to infinity becomes 1 to infinity. Okay, likewise if this summation is for even to infinity, that is n takes the values only even values to infinity means, that is here n takes the value 2, 4, 6, 8. It doesn't take any odd values. Okay, so if you want to change this to 1 to infinity, that is summation n takes values from 1 to infinity, means what you are going to do? You just replace this n by 2n. Suppose if you are having n here, means if you want to change this summation from even to infinity as 1 to infinity, means you just replace n by 2n. If you replace n by 2n, what happens? This even to infinity becomes 1 to infinity. Okay, so r to infinity, summation r to infinity is to be replaced, is changed to sigma n is equal to 1 to infinity. Then you have to replace n by 2n minus 1, and sigma n is equal to even to infinity is changed into sigma n is equal to 1 to infinity. Then you have to replace n by 2n. Okay, this is one of the important point you should remember. Right, now let me have a short look over the general form of the Fourier series along with the formulas which we are going to use to calculate the Fourier coefficients a0, an and bn. Here let f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. Here a0 is equal to 1 by pi integral 0 to 2 pi f of x dx. This is the formula we use it to calculate a0, and an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So just go through this formula once again. This is a very important formula. Most probably we have to discuss here the problem under 0 to 2 pi alone now. So here the function is given also in the interval 0 to 2 pi. So you are going to just recall this. Just remember these general form of f of x along with a0, an and bn. Okay, now let me move on to the problem. So this is what the given problem. Expand f of x is equal to x, that is in the interval 0, 2 pi. Sorry, x takes that is x is defined in the interval 0, pi, whereas 2 pi minus x, that is defined in the interval pi, 2 pi. So here the length of the interval is 2 pi, 0 to 2 pi, but from 0 to pi, the function f of x takes the value x, whereas from pi to 2 pi, the function f of x takes the value 2 pi minus x. Okay, so from 0 to pi it takes the value x, whereas from pi to 2 pi it takes the value 2 pi minus x. Okay, so instead of the function taking a single value, that is instead of taking f of x as only one function value in the whole interval 0 to 2 pi, it is a splitted interval. It will take some value of function, that is x in one interval, and some other value, that is 2 pi x in the other interval. Okay, so here itself we do the same procedure that is what we have do in case of previous problems, but instead of having one interval we are having two. Okay, for calculating a0, an and bn. Okay, that's the only difference. Right, now let us first write down what is given. So given function is your f of x, that is equal to x and 2 pi minus x. Here x is defined in the interval 0, 2 pi, and 2 pi x is in the interval pi to 2 pi. Now let me write the general form of the Fourier series. F of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. You take such equation number 1, where your a0 is equal to 1 by pi integral 0 to 2 pi f of x dx, and an is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx, and bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. You take this equation number 2, and this is equation number 3, and this one is equation number 4. After calculating the values of a0, an and bn, let me substitute in equation 1, then the problem will be over. Let me now first calculate the value of a0. So for that we make use of equation 2. So from equation 2, So the formula we are going to use for calculating a naught is equal to 1 by pi integral 0 to 2 pi f of x dx. So listen carefully. So the given function f of x is equal to f of x is equal to x, that is defined in the interval 0 comma 2 pi, and 2 pi minus x, that is defined in the interval pi comma 2 pi. Okay. So now what I am going to do here is I am going to split this interval into two parts. That is, one is from, that is, instead of having a single integral, here we are having two functions defined in two separate intervals in 0 comma 2 pi. So one interval is from 0 to pi and another interval is from pi to 2 pi. Okay. So that is equal to 1 by pi. I am going to split this integral into two, that is 0 to pi plus pi to 2 pi as another integral. Okay. In 0 comma pi the function takes the value x, right? So in 0 comma pi your f of x is x dx, whereas in pi to 2 pi the function takes the value 2 pi minus x, that is 2 pi minus x dx. Okay. Now we are going to integrate this as usual, that is 1 by pi of, when integrating x with respect to x, that is you get x square divided by 2. Here the limit is from 0 to pi, plus, now I am going to integrate this. So if you are going to integrate, that is here you have 2 pi alone, that is 2 pi dx. So you get 2 pi dx is nothing but 2 pi x, right? That is 2 pi dx alone, right? That is 2 pi integral dx is x. Okay. So 2 pi x minus x dx. X dx is nothing but x square divided by 2. So the limit is from, sorry, here the limit is from pi to 2 pi. Now let me substitute the limit, upper limit minus lower limit as usual. So here we substitute the upper limit as pi. If you substitute the upper limit as pi, what happens? You get pi square divided by 2 minus, coming to the lower limit, 0. 0 square by 2 is nothing but 0. So we simplify this term. Let us go to the next term here. So let me substitute upper limit. So for that I am going to put a small parenthesis. Okay. So upper limit. So upper limit minus lower limit, and close this small parenthesis and close this big bracket. Okay. Now here you are having two portions, you have x. So first replace this x by 2 pi. What happens? 2 pi, that is 4 pi square. 2 pi product 2 pi, 4 pi square, minus, here if you replace this x by 2 pi, what happens? 4 pi square, that is 2 pi square. 2 pi the whole square is nothing but 4 pi square divided by 2, right? Minus, coming to the lower limit, in lower limit you are having pi. Now you replace this x by pi, what happens? Pi, 2 pi product pi. 2 pi product pi is nothing but 2 pi square, minus, replace this x square by pi square. Now 2 pi square minus pi square by 2. Let me simplify this, that is 1 by pi. Here you have pi square by 2. Okay, so leave this 0. So pi square minus, sorry, pi square divided by 2 plus. So let me take the LCM now here. So if you take an LCM, what happens? That is 8 pi square, that is 4 2s are 8, right? 8 pi square minus 4 pi square divided by 2, minus, here itself if you take an LCM, what you are going to do? You just multiply this 2 by 2, that is 4 pi square minus pi square divided by 2. Okay. Now let me simplify this. So that is where a naught is equal to 1 by pi of, let us first write down the first term as it is. Okay, of pi square divided by 2, pi square divided by 2 plus, look at here, 8 pi square minus 4 pi square, that is we have only 4 pi square divided by 2. So plus 4 pi square divided by 2. So plus 4 pi square divided by 2. And then minus. Look at here. Plus here. You are having minus. So plus into minus. Minus. 4 pi square minus pi square is nothing but 3 pi square. 3 pi square divided by 2. Before that you have minus symbol. So minus 3 pi square divided by 2. So minus 3 pi square divided by 2. That's all. Let us simplify this. So that is equal to 1 by pi of. So all of them having same denominator, that is 2. So here you have pi square, here 4 pi square, that is you get 5 pi square minus 3 pi square. What happens? That is equal to 1 by pi of 5 pi square minus 3 pi square is nothing but 2 pi square, isn't it? 2 pi square divided by 2. So 2 being cancelled, so one of the pi is also cancelled. So remaining it only 1 pi. So A0 is equal to pi. So we calculated the value of A0. Next we calculate the value of AN. So for that from equation 3, we know the formula for calculating AN, which is equal to 1 by pi integral 0 to 2 pi f of x cos nx dx. As I told you already, f of x is defined in two subintervals. The first subinterval 0, pi, function takes the value x. Whereas in the second subinterval pi, 2 pi, the function takes the value 2 pi minus x. Okay. Now, I am going to split this integral into two parts. That is 1 by pi integral 0 to pi as one integral and pi to 2 pi as another integral. So in 0, pi, in 0 to pi, the function f of x takes the value x. So here you have x cos nx dx. Whereas in pi to 2 pi, the function f of x takes the value 2 pi minus x. So 2 pi minus x cos nx dx. So now what I am going to do here is I am going to integrate these two integrals separately and substitute in an. Okay, so for that you I am going to take 1 by pi inside. So 1 by pi integral 0 to pi x cos nx dx plus 1 by pi integral pi to 2 pi 2 pi minus x cos nx dx. Okay, so you take this as some integral I1 and this as your I2. So an is equal to I1 plus I2. You take some general equation A. So after calculating the integral values of I1 and I2, substitute in equation A and that gives you the value of AN. Okay. Now, let me now first calculate I1. So your I1 is 1 by pi integral 0 to pi x cos nx dx. So I1 is equal to, now I1 is equal to 1 by pi integral 0 to pi x cos nx dx. You know the formula integral uv dx, isn't it? That is uv1 minus u dash v2 plus etc. So this is a product of two functions involving the variables x. So we are going to integrate this using the formula integral uv dx. So for that your u is x, let me take u as x and v as cos nx. Now let me integrate this using that formula. So u v1, u is first write u as it is v1. v1 is nothing but just integrate cos nx. Integrating cos nx you get sin nx divided by n, then minus. Now this is your u, and this is your v1, isn't it? Now you are going to differentiate this x, that is u dash. Your next term is u dash v2, that is differentiating the first term and integrating the second term. Okay, that gives you u dash v2, right? So differentiating x, you get, differentiating x, you get 1, and integrating this v1, so you have 1 by n as a constant, take it as it is. While integrating sin nx alone, you have minus cos nx divided by n. Already you have 1 more n, so that becomes n square. So with the limit from 0 to pi. So let me start up to this. Suppose if you put plus, then the next term is, now you are going to differentiate this. So differentiate this means 0. So we may not have after this. Okay. So we have only 2 terms. So that is equal to 1 by pi. So x sin nx by n, and this minus and minus becomes plus cos nx divided by n square, with the limit from 0 to pi. Let me now substitute the limits, that is 1 by pi. Let me first substitute the upper limit first. So first mark the x position. So at these 3 places we have x. So put a big parenthesis, inside that you have a sub parenthesis. Okay. Now this is for upper limit minus lower limit and close the square bracket. Now let me first substitute the upper limit. If you substitute pi for x, what happens? First look at the side term, sin n pi. You know the value of sin n pi. What is the value of sin n pi? Sin n pi is 0. So first term becomes 0 plus cos n pi. Okay, if you replace this x by n pi, what you get? Cos n pi. You know the value of cos n pi, that is minus 1 whole power n. Cos n pi is equal to minus 1 whole power n, isn't it? So minus 1 whole power n divided by n square. Upper limit over. Minus, coming to the lower limit, that is 0. If we replace this by 0, what happens? 0 into anything? 0. Entirely the first term becomes 0. Plus cos n into 0, that is cos 0. You know the value of cos 0. Cos 0 is equal to 1. So 1 divided by n square. So simplifying this, 1 by pi minus 1 whole power n divided by n square. So plus into minus, minus 1 by n square. So this is the value for your I1. We may not simplify further, so let me stop up to this. So this is your I1. Next we calculate I2. Now your I2 is equal to 1 by pi. You know what is our I2? So your I2 is equal to 1 by pi integral pi to 2 pi minus x cos nx dx. Okay. So your I2 is equal to 1 by pi integral from pi to 2 pi minus x cos nx dx. Now this is of the form uv, integral uv dx, that is uv1 minus u dash v2 plus etc. So let me take the first one as 2 pi minus x as u and v as cos nx. Now let me integrate this using this Bernoulli's formula. So 1 by pi u is nothing but 2 pi minus x, and v1 that is integrating cos nx, you get sin nx divided by n, that is sin nx divided by n uv1 minus u dash v2. U dash is nothing but this is your u, this is your v1. U dash is nothing but you are going to differentiate this. While differentiating, 2 pi is a constant, so that becomes 0. Minus, while you differentiating x, you get 1. So you have minus 1 alone. Okay, minus 1. So product v2 you are going to now write down here. So integrating v1 gives you v2. So this is your v1. So take 1 by n as a constant. So integrating sin nx, you get minus cos nx divided by n. So already you have one more in the denominator, so you have n squared in the denominator. So that's all. So pi to 2 pi. So we may not proceed further because if you put plus in the next term, differentiating this becomes 0. So let me stop up to this. So whenever you get a constant of derivative, any derivative, we have to stop up to this. Okay. So that is equal to 1 by pi. Let me simplify these terms and then next we substitute the limits. Okay. So 2 pi minus x of sine nx divided by n. So here you have 3 minus. So 3 minus term become minus itself. So minus cos nx divided by n square with the limit from pi to 2 pi. Let me now substitute the limit. First we substitute upper limit and then go for the lower limit. Okay. So for that put a big parenthesis. Inside that you have 2 sub parentheses. So one for upper limit minus lower limit and close the parenthesis. So bracket is very important. Okay. Now let me first substitute the upper limit. So here your upper limit is 2 pi. So let me mark the portions of x first. So at these 3 portions we have x. So first one 2 pi minus 2 pi. If you replace x by 2 pi, what happens? 2 pi minus 2 pi 0. So product of anything you get 0. So first term becomes 0 minus cos 2 pi. So that is cos n of 2 pi. That is cos 2n pi. You know the value of cos 2n pi. Cos 2n pi value is plus 1. So you have 1 divided by n square. So upper limit over. Coming to the lower limit, here you have pi. If you replace x by pi, look at the sine term first. Sine n pi. Okay. Sine n pi value is 0. Okay. So sine n pi value is 0. So if you replace this x by pi, this entire term becomes 0. So first term becomes 0 minus cos n pi. Cos n pi value is minus 1 whole power n. So cos n pi is minus 1 whole power n divided by n square. Let me simplify this. That is 1 by pi of, here you have minus 1 by n square. Here minus of lower limit. So this minus and minus become plus minus 1 whole power n divided by n square. So we may not simplify further. So let me stop up to this. So this is the value of your second, that is I2. Okay. 1 by pi of minus 1 by n square plus minus 1 whole power n by n square. Now let me substitute these both I1 and I2 values in an. So that is in equation A. So from A, what we write for an? An is equal to I1 plus I2. So your I1 is equal to, what is your I1? So your I1 is equal to 1 by pi of minus 1 whole power n by n square minus of 1 by n square, right? So that is equal to 1 by pi of minus 1 whole power n by n square minus 1 by n square plus your I2 is 1 by pi minus 1 by n square plus minus 1 whole power n by n square. So minus 1 by n square plus minus 1 whole power n by n square. Now here we have 1 by pi as a common term. Take it outside. So 1 by pi of minus 1 whole power n minus 1 and minus 1. So this plus minus becomes minus plus. The next term plus minus 1 whole power n whole divided by n square, because all of them came in the common term n square. Okay. So what happens? That is equal to 1 by pi 2 times minus 1 whole power n, we have minus 2. Okay. Divided by n square. You take 2 as a common term, take it outside. So if you take 2 outside of the parenthesis, we have 2 divided by pi n square. Take this n square to outside. You have minus 1 whole power n minus 1. So again we need to simplify further. So for that, what I am going to do is an is equal to, so if you are having this term, that is minus 1 whole power and minus 1 or plus 1, something like this, means definitely the series exists for only odd or even terms of the series. Okay, so let me first substitute only for this n. Okay, if you substitute n is equal to 1, what happens? If you substitute n is equal to 1, what happens? Minus 1, that is nothing but minus 2. Minus 2 is multiplied with 2, means you have minus 4 by pi n square. That is, if n is odd value, that is, I am going to give odd and even values. Odd values start from 1, 3, 5, 7, etc. Okay, whereas even values start from 2, 4, 6, 8. Okay, so let me divide this. Whether this series exists for, that is the summation of a n value exists for all odd values or even values. So for that, let me first substitute n is equal to, I have one odd value 1. So if you substitute n is equal to 1, means you get some value, that is minus 2 for this parenthesis. Inside this parenthesis, simplifying this, you get minus 2. Minus 2 product, so multiply this 2, means you get minus 4 by pi n square. Now if you substitute, let me check it for even terms. So if you substitute n is equal to 2, what happens? Minus 1 whole power 2 minus 1. Minus 1 whole square is plus 1 minus 1. What happens? 0. So this becomes 0. 0 into anything. So 0 into anything, 0. So doesn't exist for even terms. Okay. So a n value exists only for odd values, not for even values. Okay. Now, next we calculate the value of bn. So for that we make use of equation 4. So from equation 4, the formula we are going to use for calculating bn is equal to 1 by pi integral 0 to 2 pi f of x sin nx dx. So as you know already, the given function is defined in two subintervals. The first subinterval, that is x, in the subinterval 0 comma pi, whereas in the interval pi comma 2 pi, it takes the value 2 pi minus x. So I am going to divide this integral into two parts. So integral 0 to pi and pi to 2 pi. Okay. In 0 to pi, it takes the value x. So f of x takes the value x. So x sin nx dx. Whereas in pi comma 2 pi, it takes the value 2 pi minus x. So you have here 2 pi minus x sin nx dx. Now what I am going to do here is, I am going to separate this integral into 2. So for that, take 1 by pi inside of the parenthesis. So 1 by pi integral 0 to pi x sin nx as one integral plus 1 by pi integral pi to 2 pi minus x sin nx dx as your another integral. So this takes us I3 and I4. Okay. So let me separately, so this is your I3 and this is your I4. So let me separately calculate the integral values I3 and I4 and substituting, take this as some equation of b. B, that gives you the value of bn. So let me first calculate I3. So your I3 is nothing but 1 by pi integral 0 to pi x sin nx dx. Now your I3 is equal to 1 by pi integral 0 to pi x sin nx dx. So this is of the form integral uv dx, right? Your u is x and v is sin nx. So you know the formula, integral uv dx is equal to u v1 minus u dash v2 plus etc. So here, while integrating using Bernoulli's formula, you have 1 by pi u is x and v1 is, and while integrating sin nx, you get minus cos nx divided by n. So this is your u and this is your v1 minus u dash. So differentiating x you get 1, right? And again you are going to integrating this v1. So take minus 1 by n as a constant. So integrating cos nx you get sin nx divided by n. So already you have one more n in the denominator, so that becomes n square. So the limit is from 0 to pi. Okay. Now let me simplify this. So that is minus and minus becomes positive. Take this minus to the front. Okay. So 1 by pi of minus x cos nx divided by n plus sin nx by n square with the limit from 0 to pi. Now let me substitute the limits. So that is equal to 1 by pi, put a big parenthesis. So we have inside this we have two sub parentheses. One is for upper limit and another one is for lower limit. So now let me first mark the portions of x. So for these three portions we have x. So first let me substitute pi. So minus pi. So minus pi cos n pi. You know the value of cos n pi, isn't it? Cos n pi, that is minus 1 whole power n, right? So minus pi of minus 1 whole power n divided by n plus, if you replace this x by pi, what happens? Sin n pi. What is the value of sin n pi? 0. So you get the entire term becomes 0. Minus, coming to the lower limit, if you replace this x by 0, what happens? 0 into anything? 0, because x is in product. Okay, so this term becomes 0 plus, you know the value of sin n 0, that is sin 0. What is the value of sin 0? 0. So there is no lower limit. So your I3 is 1 by pi of minus pi minus 1 whole power n divided by n. Okay. So your I3 is 1 by pi minus pi of minus 1 whole power n by n. We can't simplify this further. So this is your I3. Next we calculate I4. So what is your I4? I4 is 1 by pi integral pi to 2 pi minus x sin nx dx. So now let me calculate I4. I4 is equal to 1 by pi integral pi to 2 pi. Okay, 2 pi minus x sin nx dx. So this is your I4. So this is on the form uv dx. You know the formula, integral uv dx is equal to uv1 minus u dash v2 plus etc. So let me integrate this using that formula. U is 2 pi minus x v1. While you integrating sin nx, you get minus cos nx divided by n minus u dash. U dash is nothing but differentiating 2 pi minus x. So when differentiating 2 pi, you get 0 minus x. If you differentiate x, you get 1. So before that you have minus, so you minus 1 of. So now you integrate this. So this is your u and this is your v1, isn't it? Integrating this, what you get? Minus 1 by n as constant, take it outside. Integrating cos nx, you get sin nx divided by n. So already you have one more n in the denominator, so you get n square. So the limit is from pi to 2 pi. Let me simplify this first. So take this minus to the front, minus 2 pi. Take this minus to the front. Okay. Minus of 2 pi minus x cos nx divided by n. Here you have 3 minus. So minus sin nx divided by n square with the limit from pi to 2 pi. Now let me substitute the limits. For that, first let me mark the portions of x. So these three portions we have x term, right? So first substitute upper limit. If you substitute upper limit, 2 pi is the upper limit. If you replace x by 2 pi, what happens? 2 pi minus 2 pi. So this is for upper limit minus lower limit. And just put the symbol, parenthesis first, okay? So 2 pi minus 2 pi, what happens? 0. 0 into anything? 0. Minus cos n 2 pi. You know the value, sorry, sin n 2 pi. Sin 2n pi value is 0. Okay. So you have here 0. There is no upper limit. Minus, coming to the lower limit, if you replace this 2 minus of this x by pi, what happens? 2 pi minus pi, you have pi itself. Okay. Minus pi of cos n pi. You know the value of cos n pi. What is the value of cos n pi? Minus 1 whole power n by n. So minus 1 whole power n by n. So first term you have minus pi minus 1 whole power n by n, minus, coming to the sine term, sin n pi. Sin n pi value is 0. Isn't it? So here this term becomes 0. Let me simplify this. So 1 by pi. So we don't have it. This term minus, here you have minus and minus become plus pi of minus 1 whole power n divided by n. Okay. So your I3 value is 1 by pi minus pi of minus 1 whole power n divided by n. So here itself you get the same value. Instead of minus, here you have plus, isn't it? So let me substitute these two in equation B. What is your equation B? That gives you the value of Bn. That is, Bn is equal to I3 plus I4. We calculated the value of I3 as 1 by pi minus pi of minus 1 whole power n divided by n. Whereas your I4 value is 1 by pi of minus 1 whole power n divided by n. So look at these two terms. So if you take 1 by pi as a common term, take it outside, what happened? Minus pi of minus 1 whole power n by n plus pi of minus 1 whole power n by n. So same in magnitude, opposite inside. So both of them being cancelled. So 1 by pi of 0, which implies you get the value of Bn is 0. Now let me substitute all these values in equation 1. So from equation 1, so your f of x is equal to a0 by 2 plus sigma n is equal to 1 to infinity an cos nx plus sigma n is equal to 1 to infinity bn sin nx. Let me substitute the values of a0. The value of a0 we have calculated as pi divided by 2 and plus an value we calculated as, that is, an is equal to, that takes the value minus 4 divided by pi n square. If n is odd, and it takes the value 0 if n is even. So which means it takes only odd values. Odd value means it takes only 1, 3, 5, etc. So instead of writing sigma n is equal to 1 to infinity, you have to write n is equal to odd to infinity, because we have only the value for a for odd terms alone, that is equal to minus 4 divided by pi n square cos nx plus bn value is 0. So if bn value is 0 means this entire term becomes 0. So that is equal to pi by 2. If you take the constants outside, that is here the constant is 4 pi along with minus, so minus 4 by pi sigma n is equal to r to infinity. Inside that you have 1 by n square alone cos nx. Suppose, so up to this we have to stop the problem. Okay, suppose if you like to convert this n is equal to r to infinity as n is equal to 1 to infinity, so your f of x is, or you can write your f of x as pi by 2 minus 4 by pi sigma n is equal to 1 to infinity. Only the change is here n is varies from odd term to infinity. I am going to interchange that to 1 to infinity, means what I am going to do? As I told you already, you have to replace that n, this n alone, not, sorry, this and this n, okay? This 2 and by, okay, 2n minus 1, okay? That is what initially I told you. So you have to replace both these n by 2n minus 1. If this Summation is for odd terms only. Okay. So if you replace n by 2n minus 1, what happens? 1 divided by 2n minus 1 whole square, product cos of 2n minus 1x. That's all. Okay. Hope you got a clear idea about how to expand the given function as a Fourier series in the given interval 0, 2 pi. So instead of giving the function as a single function in the whole interval, if the given function is in terms of splitted intervals, then how can we expand the given function as a Fourier series? Hope you got a clear idea about this in detail. Thanks for watching. See you all again in my next video.